All right, so you wanted to really get this whole SepLM thing.
Yeah.
And trust me, it gets really wild.
It's pretty out there.
We are diving into some serious cutting-edge research here.
For sure.
With this paper called SepLLM, Accelerate Large Language Models by Compressing One Segment into One Separator.
Big title.
It's a mouthful.
Uh-huh.
But the goal is pretty straightforward, making those powerful large language models faster and able to handle much longer chunks of text.
Huge challenges.
Two huge challenges in the field right now.
Absolutely. It really flips the script on how we've been thinking about making LLMs better.
Oh, okay.
Instead of just throwing more computing power at the problem.
Right.
This research suggests a smarter, more elegant approach.
So less brute force, more finesse.
Exactly.
I like it.
Yeah.
But before we get ahead of ourselves, let's start with the basics.
Okay.
Why is speed such a big deal with these LLMs? I mean, computers are pretty fast these days.
They are, but LLMs are anything but basic.
Okay.
We're talking about millions, sometimes billions of parameters that the model has to juggle.
Right.
Think of it like trying to read an entire library at once.
Oh, gosh.
It's going to take a while.
Okay, yeah.
And that's just for short pieces of text.
Okay, I'm starting to see the problem.
Yeah.
But you also mentioned handling longer texts as a major hurdle.
Right.
Is that just because of the sheer volume of words? Or is there something else going on?
There's a deeper issue at play here.
Okay.
LLMs rely on this attention mechanism to understand the relationships between words.
Right.
But the more words you throw at it,
the
more complex those relationships become.
Right.
And the slower the whole process gets.
Okay.
It's like a party. The more people you invite, the harder it is to keep track of all the conversations.
Makes sense.
Right.
So LLMs are inherently slow. And longer texts just make things exponentially worse.
Pretty much.
That's not exactly ideal if we want these models to do things.
Right.
Like summarize the whole book, right?
Exactly. And that's where this SepLM research comes in.
Okay.
With a truly mind-blowing discovery.
Okay, now I'm intrigued.
Yeah.
What'd they see?
So they visualized how these LLMs pay attention to different parts of a text.
Right.
And what they found was totally unexpected.
Okay.
They found that those seemingly meaningless separators, things like commas, periods, and even line breaks,
Oh, wow.
were getting way more attention from the models
Really?
compared to meaningful words,
Interesting.
like nouns and verbs.
Okay.
Almost like the LLMs were fixated on the punctuation.
Wait, hold on.
Yeah.
The punctuation was more interesting to the model than the actual words.
It seems that way.
That seems counterintuitive to say the least.
It does, doesn't it?
Yeah.
But this unexpected finding led the researchers to ask a fascinating question. What if these separators aren't just random punctuation marks, but actually act as a sort of shorthand, compressing information about the segments they separate? Almost like a secret code that the LLMs are picking up on?
So like a secret language?
Yeah.
That only the LLMs understand?
Kind of.
That's a wild thought.
It is.
But if that's true...
Yeah.
Couldn't you just focus on those separators and ignore most of the other words?
That's the genius of SepLM.
Okay.
It basically does just that.
Wow.
It keeps only 3 types of tokens during processing. The initial tokens for context.
Right.
A few neighboring tokens for local relationships.
Yeah.
And crucially, all those separator tokens.
Okay.
By focusing on these, they found they could drastically reduce the number of tokens.
Right.
The model has to process, making it way faster and more efficient.
So it's like reading just the chapter titles and a few key sentences.
Right.
Instead of the whole book.
Exactly.
But still getting the gist of the story.
That's a great analogy.
Okay.
And the really shocking part is that it actually works.
Wow.
The researchers put SepLLM to the test on some pretty challenging benchmarks.
Okay.
Like GSM-8K COTI, which involves solving math problems.
Right.
And MMLU, which tests general knowledge and reasoning across different domains.
So these are tasks where you'd expect losing all those meaningful words.
You would think so.
To hurt performance.
Right. What happened?
Here's the kicker.
Okay.
Even without retraining the original LLM, simply applying the SepLLM approach to an existing model, like Llama 3.8b, resulted in comparable performance to the full attention model on both of these benchmarks.
Hold on.
Yeah.
So by ignoring most of the words, They got similar results.
Pretty much.
That's impressive.
Yeah.
But how much more efficient with it?
Well, we're talking about speed here, right?
Well, the efficiency gains were significant.
Okay.
For example, on the GSMA-K-SUTI benchmark,
yeah,
SepLLM achieved this level of performance while using only 47%.
47%
of the key value cache.
Okay, for those of us who don't spend all day thinking about AI,
Sure.
Can you explain what this cache thing is and why 47% is a big deal?
The key value cache is essentially the LLM's short-term memory.
Okay.
It's where it stores the information it needs to process a given text.
Yeah.
So using less of it means the model is working much more efficiently.
Okay.
It's like being able to solve the same math problems using less scratch paper.
Okay, that makes sense.
Yeah.
So SepLLM is faster, but it still gets the job done. That's pretty impressive. But I'm guessing they didn't stop there, right?
You're right. They wanted to see if they could bake this SepLLM approach into the training process itself.
Okay.
Not just apply it afterwards.
I'm ready for round 2. What did they find?
When they trained a model from scratch using the SepLLM architecture, it achieved lower training losses than a standard transformer model.
Wow.
While using significantly fewer FLOPs.
Fewer FLOPs.
FLOPs, or floating point operations, are basically a measure of how much computational effort is required.
So not only is it faster and more memory efficient during inference, but it's also more efficient to train in the first place.
It is.
That's a game changer, especially if we're talking about making these massive models more sustainable.
Absolutely. And to really drive home the point that those separators are the secret sauce.
Okay.
They did a head-to-head comparison against another model called Screaming LLM.
Let me guess. Streaming LLM doesn't use separators.
You got it.
Okay.
It focuses on initial and neighboring tokens.
Yeah.
But ditches the separator information.
Right.
And the results were striking.
Okay.
Streaming LLM consistently performed worse, even when it was given more memory to work with.
Oh, wow.
It was like trying to solve a puzzle with half the pieces missing.
Wow. Okay, so those separators are doing a lot more heavy lifting than we initially thought.
Yeah.
They're not just random punctuation marks. They're like information anchors for the entire text.
That's a great way to put it.
Okay.
It really makes you wonder what else we might be overlooking.
Yeah.
In our understanding of how LLMs work.
That's true.
We tend to think of language in terms of words and their meanings.
Right.
But maybe there are these other layers of structure and encoding going on that we're only just beginning to grasp.
Mind-blowing stuff.
Yeah, it is.
So we've seen that SepLLM is faster, more efficient, and can even be integrated into the training process.
Yes.
What else did they discover?
They also looked at how to adapt existing LLMs to the SepLLM architecture.
Right.
Because it wouldn't be very practical if we had to retrain every single model from scratch.
Right. That's a great point. So how did they do it?
Thankfully, no, they didn't have to go back to school or anything.
Okay, good.
They developed a technique for quickly adapting a pre-trained LLM to the SepLLM architecture.
All right.
Through a short post-training phase.
Okay.
Essentially, you take your existing LLM and fine-tune it on a smaller data set.
Okay.
Using the SepLLM rules for token selection.
So you're giving your old LLM a quick software update.
Exactly.
And this actually works.
It does.
They can take an existing LLM and make it more efficient without sacrificing performance.
That's the beauty of it. They were able to significantly improve the efficiency of existing models without compromising their capability.
That's like getting a performance boost.
It is.
Without having to buy a whole new computer.
Exactly.
This SepLLM is sounding less like a cool idea and more like something that could actually change how we use LLMs.
I think so.
In the real world, I'm already thinking about all the possibilities.
It's pretty exciting.
And that's just the beginning.
Right.
Remember how we talked about LLMs struggling with those super long texts?
Yeah.
Well, SepLLM turns out to be exceptionally good at handling those. Even texts that are millions of tokens long.
Crazy.
We're talking about processing entire books or ongoing conversations.
It's pretty wild.
Okay, now we're getting into sci-fi territory.
Yeah.
But did it actually work?
Well,
could it really understand those super long texts?
They tested it on a data set called PG-19.
Okay.
Which is a collection of long literary works.
Gotcha.
And get this, SepLLM consistently outperformed streaming LLM.
Really?
In terms of both perplexity
and
inference time.
Wait, back up for a second.
Yeah.
What's perplexity?
Perplexity is basically a measure of how surprised the model is by the text.
Okay.
The lower the perplexity,
Yeah.
the better it understands what's going on.
Okay.
Think of it like reading a mystery novel.
Uh-huh.
If you're constantly surprised by the twists and turns,
Yeah.
it probably means you're not following the plot very well.
Ah, okay. So lower perplexity means the LLM is less surprised by the text.
Exactly.
Meaning it's understanding things better.
Right.
Got it.
Yeah.
So SepLLM not only could handle these massive texts, but also understood them better and did it faster.
That's right.
Wow.
And this ability to process truly long contexts opens up some incredible new applications for LLMs.
Okay.
Imagine a world where you can ask an LLM to summarize an entire book.
Okay.
Understand the nuances of a long-running negotiation.
Wow.
Or even model the development of a character's personality.
That's amazing.
Over an entire series of novels.
Okay, my mind is officially blown.
Yeah.
We're talking about LLMs becoming truly intelligent assistants, not just glorified autocomplete tools.
Exactly, and SepLLM takes us a big step closer to that reality.
This is all incredibly fascinating.
It is.
But I know you love to dig into the nitty-gritty.
Oh, yeah.
The paper mentioned something called ablation studies.
They did.
What are those, and what do they reveal about how SepLLM works?
Yes. The ablation studies.
Okay.
They're a classic way to figure out
Yeah.
which parts of a system are truly essential.
Okay.
Imagine taking apart a clock to see which gears actually make it tick.
Right.
That's what these studies did for SepLLM.
Gotcha.
And what they revealed is pretty fascinating.
All right. I'm ready for another deep dive.
Okay.
Hit me with the insights.
Well, first, they looked at the impact of those neighboring tokens.
Right.
Remember how SepLLM keeps a few of them around for context?
Yeah.
Well, they found that increasing the number of neighboring tokens generally improved performance.
Okay.
Up to a point. It's like giving the model a wider field of vision.
Makes sense.
So it can see more of the surrounding words
and
understand their relationships better.
More context usually means better understanding, right?
Absolutely.
But I'm guessing too many neighbors might start to clutter things up.
It's possible.
Did they find a sweet spot?
They did.
Okay.
There's a point of diminishing returns.
Right.
Where adding more neighbors doesn't provide much benefit.
Yeah, that makes sense.
But they also discovered something really clever.
Okay.
Even though SepLLM is all about those separators.
Right.
They found that adding a sprinkle of full attention back into the mix.
Oh, interesting.
Specifically on the first and last layers of the model.
Okay.
Provided a further boost in performance.
Wow.
Especially on tasks requiring an understanding of the entire text.
So it's like a hybrid approach.
It is.
You get the efficiency of SepLLM for most of the processing.
Yeah.
But you sprinkle in some full attention where it matters most.
Exactly.
That's pretty ingenious.
And it highlights that SepLLM isn't meant to completely replace full attention.
Right.
It's about finding the right balance between efficiency and performance.
Right. Smarter, not just bigger.
Exactly.
SepLLM is all about working smarter, not harder.
For sure.
And speaking of working smarter, they also did some digging into that separator cache, right? The LLM short-term memory for those all-important separators.
Yes. And as you might expect, the size of that cache matters.
Okay.
The larger the cache, the better the performance.
Makes sense.
Especially when dealing with those super long texts.
Right. The more you can remember, the better you can understand the big picture.
Exactly.
But I'm curious, was there anything else those ablation studies revealed about the importance of those separators?
They ran one final test that really sealed the deal.
Right.
They tested SepLLM without a technique called positional shifting, which is a way to handle the positions of tokens in a long text stream.
Okay.
And guess what? SepLLM remained relatively stable even without it.
Wow.
While streaming LLM completely fell apart.
So no matter how you slice it, those separators are the key.
It seems so.
They're not just random punctuation.
Right.
They're like the structural backbone of the text.
Right. This is a really important role.
Who knew punctuation could be so powerful?
It's a fascinating discovery.
It is.
That really challenges our assumptions about how language works.
For sure.
And perhaps how LLMs understand it.
This has been an incredible deep dive so far.
It has.
But before we wrap up this part,
I
have to ask.
Sure.
What was the most surprising or mind-blowing thing you learned from this research?
That's a good question.
Yeah.
For me, it's the sheer elegance of it all.
Yeah.
This simple idea of compressing information into those separators
Right.
and then using them to guide the LLM's attention is just brilliant.
It's amazing.
It completely changes how we think about language processing.
Yeah.
And opens up so many exciting possibilities.
I totally agree. It's like discovering a hidden language within language itself.
For sure.
And I have a feeling we're only just scratching the surface.
I think so, too.
Of what's possible with this kind of thinking.
Absolutely.
But we'll have to save that for part 2 of our deep dive.
Looking forward to it.
Me too.
All right. Sounds good.
See you then.
Yeah, see you then.
Bye.
Bye.
Welcome back.
It's amazing to think that something as simple as punctuation
I know, right?
could be the key to unlocking so much potential in these LLMs.
It is. And as we dig deeper, it really highlights how much we still don't know.
That's true.
About how these models actually work.
Absolutely. Every new discovery opens up a whole new set of questions.
For sure.
But speaking of discoveries, the SepLLM paper didn't just explain how the model works. They actually put it through its paces. With some rigorous experiments.
And that's what's so compelling about this research.
Right.
It's not just a theoretical idea. It delivers real, tangible results.
All right, let's dive into those experiments.
Oh, yeah.
You mentioned they did some work with the Pythia model, training it from scratch, using SepLLM.
Right.
What exactly did they do?
And what kind of tasks did they test it on?
They tested on a whole range of tasks.
Okay.
Designed to really push the model's abilities.
Like what?
Things like question answering.
Okay.
Where the model has to understand a question. And find the answer in a given text.
Right.
Natural language inference, which involves figuring out if one statement logically follows from another.
Okay.
And even measuring the perplexity of the model.
Yeah, we talked about that.
Which, as we discussed earlier, tells you how well it can predict the next word in a sequence.
So a pretty comprehensive evaluation.
Yeah, pretty much.
And what were the key takeaways from all these tests?
Well, first and foremost, they proved that SepLLM could be effectively integrated into the training process itself.
So you're saying this thing can learn just as well, if not better.
That's what it looks like.
Using way less brain power.
Yeah, much more efficiently.
That's incredible.
It really is a testament to the efficiency of this approach.
Yeah.
And it opens up some exciting possibilities.
Like what?
Like potentially training much larger and more powerful models.
Wow.
Using the same amount of computing power we have now.
Or training existing models much faster.
Right.
Which is great news for researchers and developers.
Absolutely.
Working with limited resources.
For sure.
But it gets even better.
Oh, yeah.
Remember those neighboring tokens that SepLLM keeps around for context?
Yeah.
They did some experiments to see how increasing the number of those neighboring tokens affected performance.
That's right.
My intuition says more context should lead to better understanding, right?
You're absolutely right. As they increase the number of neighboring tokens, the training loss decreased more rapidly.
Okay.
And the model performed better on those downstream tasks.
So it's like giving the model a wider field of vision.
Exactly.
Allowing it to see more of the surrounding words and understand the relationships between them more effectively.
That's a great analogy.
But I'm curious, did they just keep adding more and more neighboring tokens? Or was there a limit?
They found that there's a sweet spot.
Okay.
Adding more neighboring tokens helps.
Oh, right.
But after a certain point, you start to see diminishing returns.
Right, like trying to cram too much information into your brain at once.
It can be too much.
It can become overwhelming.
Right.
If that makes sense.
Yeah.
But they didn't just tinker with the number of neighboring tokens, did they?
No, they didn't.
They also experimented with that hybrid approach we talked about earlier, right?
Yeah.
The one where they used full attention on some layers of the model.
Yes, they did. And that hybrid approach, using full attention on the first and last layers, while sticking with SepLLM for the layers in between, turned out to be a real winner.
Okay.
It led to even better performance.
Wow.
Especially on tasks that require a deep understanding of the entire text.
Yeah.
Like summarizing a long article or understanding the nuances of a complex argument.
So it's like combining the best of both worlds?
It is. You get the efficiency of SepLLM for most of the processing.
Right.
But add in a bit of that full attention power where it's needed most.
Exactly.
I'm starting to see why you're so excited about this research.
It's pretty cool.
It's not just about making things faster.
Right.
It's about making them smarter.
Exactly.
And that brings us to one of the most crucial experiments in the entire paper.
Right.
The head-to-head comparison
between
SepLLM and streaming LLM. yes, the Battle of the LLMs.
That's right.
This was the one where they really wanted to prove
Yeah.
the importance of those separators, right?
Exactly. They pitted SepLM against streaming LLM, which, as you'll recall, drops all separator information on a variety of benchmarks, including those tricky math and multi-domain knowledge tasks we talked about earlier.
And I'm guessing SepLM came out on top.
You bet. SepLM consistently outperformed streaming LLM.
Wow.
Even when they gave streaming LLM more memory to work with.
Oh, wow.
It was like watching a skilled chess player. Yeah.
Go up against someone who only knew half the rules of the game.
That's a great analogy. So the takeaway here is that those separators are absolutely essential.
They seem to be.
For achieving the kind of performance we're looking for in these LLMs.
Without a doubt, they're not just random punctuation marks.
Right.
They're like little signposts that guide the LLM through the text.
Right.
Helping it to understand the structure and meaning of the information.
This is all incredibly impressive.
It is.
But I want to shift gears a bit.
Okay.
And talk about the bigger picture.
Right.
What are the implications of this research for the future of LLMs? Where do you see this technology going in the next few years?
The potential applications of SepLLM are vast, spanning across numerous industries and aspects of our lives.
Give me some examples.
We could see faster, more responsive chatbots. Search engines that truly understand what you're looking for.
Right.
And even personalized AI tutors.
Wow.
That adapt to individual learning styles.
Okay, those sound like pretty significant improvements to existing technologies.
Yeah.
But could SepLM also lead to entirely new applications
Potentially.
that we haven't even thought of yet?
Absolutely. Imagine AI assistants that can seamlessly translate languages.
Wow.
In real time.
Okay.
Help scientists analyze complex data sets.
Yeah.
Or even assist writers and artists in their creative endeavors.
That's amazing. The possibilities are truly endless.
They really are.
This is all incredibly inspiring.
It is.
But I want to make sure we're not getting ahead of ourselves.
Sure.
No technology is perfect.
Right.
So what are some of the limitations of SepLM?
Okay.
Where might it fall short?
That's an important question.
Yeah.
While SepLM is a significant breakthrough,
right,
it's still in its early stages of development.
Okay.
And there are a few areas where further research is needed.
All right, give us the reality check.
Okay.
What are some of those areas?
One challenge is the selection of separators. Right now, the choice of which separators to use is somewhat arbitrary. And it's not entirely clear what the optimal set of separators might be for different tasks or languages.
So there's still a human element involved.
There is.
Someone needs to decide which separators are important.
Right.
And that decision could impact the performance of the model.
That's right. And this is an area where further research could lead to significant improvements.
Okay.
Another potential limitation is the risk of information loss.
Okay.
While SepLLM does a remarkable job of compressing information into those separators, there's always the possibility that some subtle nuances of meaning might get lost in the process.
It's like trying to fit a complex idea into a tweet.
Exactly.
You can convey the gist of it, but some of the details might get left out.
And this can be particularly important for tasks where a high level of accuracy and precision is required, like legal or medical applications.
So separator selection and potential information loss are two areas to keep an eye on. Are there any other limitations we should be aware of?
Another area for further exploration is the generalizability of SepLM. The research so far has primarily focused on a few specific LLM architectures and tasks. And it's not yet clear how well SepLM would perform on other models or in other domains.
So we need more research to understand how well SepLM scales to different types of LLMs and different types of problems.
Exactly. But despite these limitations, I believe the potential benefits of SepLM far outweigh the challenges. It's a groundbreaking approach to language modeling that could fundamentally change how we interact with machines.
I'm inclined to agree. It's a reminder that sometimes the most innovative solutions come from looking at old problems in new ways.
For sure.
Who would have thought that punctuation could be so crucial for the future of AI?
It's a testament to the power of human ingenuity.
It is.
And the importance of always questioning our assumptions.
This has been an incredibly insightful discussion.
It has.
And I'm eager to hear more about the specific applications of SepLM and how it could impact our everyday lives.
For sure.
But we'll have to save that for part 3 of our exploration.
I'm looking forward to it.
Welcome back for the final part of our SepLM deep dive.
Yeah.
We've covered a lot of ground.
We have.
From the surprising discovery that punctuation might hold the key to unlocking faster, more efficient LLMs.
Oh, sure.
To the impressive experimental results that back up this radical new approach.
Yeah, it's a game changer.
And now it's time for the fun part.
Okay.
Exploring the potential applications of this technology and how it could change the world as we know it.
Absolutely.
I'm all ears.
All right.
Let's start with the practical stuff.
Okay.
We use LMs in so many everyday tools.
We do.
From search engines to those chatbots that seem to be popping up everywhere.
Everywhere you look.
How could SepLM improve these experiences?
Well, let's take search engines as an example.
Okay.
Right now.
Yeah.
They mainly rely on keywords to find relevant results.
That's right.
But imagine a search engine.
Yeah.
They could truly understand the context of your query.
Right.
Grasping the nuances of your language and connecting different concepts together.
So instead of just giving me a list of websites that happen to mention the words I typed, it could actually figure out what I'm really looking for.
That's the idea.
And provide more targeted, insightful results.
More relevant.
That would be a game changer.
Exactly. And SepLLM could be the key to making that happen.
Okay.
Its ability to handle long, complex queries would allow search engines to go beyond simple keyword matching and truly grasp the intent behind our searches.
And what about those chatbots?
Yeah, what about them?
They can be helpful.
Sometimes.
But they often feel clunky and limited.
For sure.
Could SepLLM give them a much-needed boost?
Absolutely, with SepLLM.
Okay.
Chatbots could become much more conversational and engaging.
Okay.
Remembering past interactions.
Oh, wow.
And understanding complex requests.
That would be a big step forward.
Instead of just responding to specific keywords or phrases.
Right.
They could follow the flow of a conversation.
Okay.
Understand subtle cues.
Interesting.
And even anticipate our needs.
So we're not just talking about slightly more efficient chatbots.
No, we're not.
We're talking about AI assistants.
Yeah.
That can actually hold a conversation. Remember what we've talked about.
Exactly.
And provide genuinely helpful responses.
You would be huge.
That's a whole different ballgame.
Precisely.
Yeah.
And these improvements wouldn't be limited to text-based interactions.
Oh, really? What else?
SepLLM could also revolutionize voice assistants.
Okay.
Making them much more accurate and responsive.
That would be awesome.
Imagine talking to your phone or smart speaker.
Yeah.
And having it understand you perfectly.
Right.
No matter how complex your request.
Okay.
Or how nuanced your tone of voice.
Okay, now I'm starting to see how SepLM could take these existing technologies to a whole new level.
It really could.
But what about those entirely new applications we touched on earlier?
Yeah, those are exciting.
What kind of revolutionary possibilities does this technology unlock?
Well, one area that I'm particularly passionate about is personalized education.
Oh, interesting.
Imagine a world where every student has access to a personal AI tutor that can adapt to their individual learning style, pace, and strengths.
Wow, that sounds like something straight out of science fiction.
It does, doesn't it?
Yeah, but how could SepLLM make this a reality?
SepLLM's ability to handle long contexts is crucial here. These AI tutors could track a student's progress over time.
Right.
Understand their learning patterns.
Yeah.
And provide guidance and feedback.
Okay.
That's truly individualized.
So it remembers what they've done in the past.
Exactly. They could even analyze a student's writing.
Okay.
Identify areas for improvement.
Wow.
And suggest specific exercises.
So we're not just talking about automated grading systems or basic online quizzes.
Right.
We're talking about AI that can truly understand a student's individual learning journey.
Yes.
And provide personalized support every step of the way.
Exactly. And this concept of personalized AI could extend far beyond education.
Okay. Where else?
Imagine personalized healthcare assistants.
All right.
That can monitor your health data.
Okay.
Provide early warnings of potential problems.
Wow.
And even suggest lifestyle changes.
That's amazing.
Tailored to your specific needs.
Wow.
And genetic predispositions.
Or AI-powered therapists.
Yeah.
That can provide mental health support, analyze your emotional state, and offer coping mechanisms based on proven therapeutic techniques.
It's pretty mind-blowing.
The possibilities are mind-boggling.
They truly are. And I believe that SepLLM could play a vital role in making these applications a reality.
Right.
Creating a world where AI is not about replacing humans,
Right.
and about empowering them, enhancing their capabilities.
It's great.
And improving their lives.
This is all incredibly inspiring.
It is.
But I want to circle back to something you mentioned earlier.
Okay.
The potential for SepLLM to enable entirely new forms of human-computer interaction.
Yeah.
Can you paint a picture?
I'll try.
Of what that might look like?
Imagine interacting with your computer using natural language.
Okay.
Just like you would with another human being.
Right.
Instead of typing commands or clicking buttons, you could simply speak or write to your computer.
Okay.
Expressing your needs and desires in a way that feels natural and intuitive.
So we're not talking about those clunky voice assistants that often misunderstand us.
Right.
Or those frustrating chatbot experiences.
Exactly.
Where you feel like you're talking to a brick wall.
Yeah, those aren't much fun.
We're talking about genuine, seamless communication.
And it's the goal.
Between humans and machines.
Exactly. And SepLLM could make this possible by enabling computers to understand and respond to complex, nuanced language.
Okay.
In real time.
Imagine having a brainstorming session with an AI that can understand your ideas, suggest new approaches.
That'd be awesome.
And even help you refine your thoughts.
Pretty cool.
Or collaborating with an AI on a creative project, bouncing ideas back and forth and pushing the boundaries of human imagination.
Now that's a future I can get excited about.
Right. A future where the lines between human and machine creativity will become blurred.
That's right.
And we can leverage the power of AI to augment our own abilities.
And I believe that SepLLM is a crucial step towards that future.
This has been an incredible journey.
It has been.
And I feel like we've only just scratched the surface.
Yeah, we've only just begun.
Of what's possible with this groundbreaking technology.
Absolutely.
But as we wrap up our deep dive,
I
have one final question, Kno.
All right, shoot.
What are your hopes for the future of SepLLM and the world of AI as a whole?
My hope is that SepLLM will inspire a new wave of innovation.
Okay.
Leading to the creation of language models that are not only more efficient and powerful, but also more aligned with human values.
Yeah.
I envision a future where AI is used to solve some of the world's most pressing problems.
Okay.
From climate change to poverty and disease,
while
also enhancing our lives in countless ways.
That's a beautiful vision.
It is.
And it's one that I share. It's a reminder that at the heart of this technological revolution lies a simple but profound goal to make the world a better place for everyone.
For sure.
And I believe that SepLLM, with its elegant approach and immense potential, could be a key player in making that dream a reality.
I couldn't agree more.
And with that inspiring thought, we'll conclude our deep dive into the world of SepLLM.
Sounds good.
I hope you found this exploration as fascinating and thought-provoking as we did.
It's been a pleasure.
Until next time, keep exploring, keep learning, and keep imagining the possibilities.
Absolutely.
Take care. See you later.
Yeah. See ya.